Hello everyone. We are going to have this session to talk about an overview of the typical methods that are being used for repair of concrete structures. And I am listing some of them and assigning some that you guys can do. And there are others as well on top of this. So what we see here is that we have the structure crack repair by epoxy injection, and we gave a video or several ones on that. And there is the surface repair using form and pour technique, and then there is that work that you're doing as far as the shock creating or the repair by spraying, whether it's high pressure or low pressure. There are other types that they are pretty much similar. So instead of form and pour, there is the other one which is form and pump techniques, for instance. And there is a spal repair of horizontal concrete surface. There is the overhead spal repair by hand application, which is a very typical one. And there is the gravity kind of feeding with resin and something else, which is protection of the steel reinforcement. I noticed in the discussion board that one of your colleagues initiated saying that a big percentage of the structures is encountering failures and repair, been encountering corrosion of steel reinforcements, and he's asking and opening the discussion of what measures can we have in place so that we can minimize the corrosion or prevent the corrosion of the steel reinforcement. Nobody have replied this, so I volunteer to reply, but I think that it is something that we need to address, and I might dedicate lecture for that, or I ask you to prepare some presentation and I give you feedback on it. Basically that post that your friend did help me to say, okay, I gauge the interest of the students, so let me give you a lecture on that. The reason I'm saying that there are several, like 4 to 4 courses of repair. What we're having for this course is just an introduction to repair. There is repair for masonry, repair for timber, repair of concrete, repair of steel, repair of pre-stressed concrete, repair of an overall structure, and there are several methods. So it's a huge list of repair methods. What we're giving is an introduction, and you can dig deeper. So hopefully by the end of this class you have a good set of repair methods, repair techniques that you can be proud of. So to address your colleague comments is that a big percentage of the concrete structures are experiencing steel reinforcement corrosion, and that is causing sort of an oxidation of the steel reinforcement, occupying bigger areas like 4 to 8 times, causing spalling of concrete and cracking of the concrete. It's like a cancer, God forbid, in the body of the concrete, and that we need to get rid of. And that is hidden within the concrete. It gives you some symptoms once things get out of control somehow. You can see that kind of rust, brownish color, just like coming out. You can see some spalling of concrete. So there are several things there, but I think I want you to focus on what causes this kind of corrosion, and you can dedicate a whole presentation that you can prepare, and I'm going to critique, and I'll be hard on you on this as well, is about the corrosion that's caused by let's say the chloride ions in the air. Corrosion is caused by the carbonation of the concrete itself. And what is that corrosion? Like, it's a galvanic kind of cycle, electrochemical process, I would say, of corrosion. And you see in that slide right here, this is a rebar. Part of it is going to be anode, part of it is going to be cathode. There is going to be a potential difference between the contaminated concrete and the sound concrete, and that can start that kind of corrosion. So the corrosion, we need 2 poles, anode and cathode, and you need a medium, which is a concrete that's moist, and that's basically what trigger this kind of corrosion cycle. And then you can have the reduction of the diameter of the steel reinforcement till you get pitting of the steel reinforcement or complete loss of the steel, and that's endangering the capacity of your structure, that's for sure. What are measures? Your friend mentioned several ones. I'm not going to repeat them. He talked about the permeability of the concrete, the soundness of the concrete, the water cement ratio, the lowering water cement ratio, using of some admixtures, make it sound concrete. This is fantastic as the first line of defense for this. There are other measures as well when we deal with that. I work in a company called Fosrock. It's a British company, and in the late 80s, they invented a method called re-alkalization and desalination of concrete, if you'd like to search it. So desalination of concrete, meaning that they are extracting the salt out of the concrete itself with an electric current. So they are reversing basically this kind of electrochemical process of corrosion, reverse it so that the chlorides are going to migrate away from the steel reinforcement to the surface of concrete, and they're going to be washed off. So that is something that you might be interested in addressing in one of the future presentations that we're going to assign. Other methods is just like applying a zinc component, a sacrificial anode to the steel reinforcement as well. And this is one of them, which is anode, which is protecting the steel so that when the corrosion comes, then this is going to corrode and saving the rebars. That part right here is chloride free patch repair that you're having, and that part right here is chloride contaminated concrete. So if things get out of control, all you need to do is like knock out the concrete cover and get to the steel reinforcement and remove the corrosion and the rust from the steel, and like get to the sand of concrete and apply component, the bonding agent to the concrete, and then apply another zinc based product to the steel reinforcement for protection, and then apply the repair mortar. This is a hand application technique, but I just wanted to give you some feedback on that because your colleague initiated this, and this is really great. So what you see in that slide right there is just nothing but an attachment, embedded galvanic anode to the steel reinforcement in the patch cavity. The reason for that is to protect the steel in the concrete adjacent to the patch. And this galvanic anode is reducing, as I mentioned, the corrosion activity in the steel reinforcement in the vicinity of the installed anode. So this is something localized. But what I'm saying is that if that cancer or corrosion prevails in the concrete, this is not going to be the only method, but rather you would like to treat the whole body of concrete with the desalination method that I mentioned earlier. So for this method and for this anode that you're having right there, they are installed in the area of the concrete when you have some sort of high alkalinity activity, high alkalinity, high likelihood of corrosion activity, high likelihood of rust and occurring right there. High alkalinity is something good for the concrete that is protecting the steel reinforcement. High corrosion is something that we'd like to get rid of or avoid. So this type of anodes that is installed provide like improved protection for the reinforcing steel. So I hope that helped initiate the discussion, if you wish, so that you can reply to your colleague and you can talk about the galvanic technology, you can talk about the embedded galvanic anodes, and it is really interesting so that you can see how can you protect the steel reinforcement. Other things that we can talk about, oh, here we go. This is the galvanic technology and the embedded galvanic anodes. Other thing is some of the methods that you probably can research is the spar repair by low pressure, and that is similar to the wet mix shotcreting that we talked about, or that you are researching right now, but it's happening at a lower pressure, lower velocity, and you can get closer to the damaged part, and you can apply it using a small concrete pump or heavy-duty grout, and you can force this grout into the cavity or the part. And the bond, you need to make sure that this is gonna bond, the new material is gonna bond to the substrate, and that can be achieved through proper surface preparation, that's for sure. And the low velocity impact of that method as well and the material properties of this mortar that you are using. So you're getting very much closer to the surface, and you can get this application in tight spaces. So this is contrary to the massive shot creating that you have before. This one, you can go it into tight spaces, and it can stick to the substrate, and that is a fantastic method that can be used. Other methods as well, which is the surface repair using the form and pump technique. As you can see, the formula is being done right there, and then you can pump the concrete either from the bottom or from the top if there is an opening right there, and that is also another type of technique that you can think of. The other thing is a vertical and overhead spall repair by hand application. It's similar to the form and pour that we mentioned earlier, but this is using the hand application, and that has been used extensively in many repair incidents to repair the vertical and the overhead surfaces for columns, for walls, for beams, for soffits, for the facade of the structure. You can see that over and over. Even when I took the students to field trip to gate precast, some of the precast elements that's been fabricated, some of them have minor damage at the end and stuff, and you use this kind of hand application repair so that you can get this up to the bar, basically up to the expectations for a final product. So you're using the sponges, you're using the wooden floats or the wood floats, and or the steel trowel, and you can have the desired finish that you want for that mortar. So this is something else. I just wanted to share that with you guys, that there are several methods, and I'll be more than happy to assign one or two of this as an opportunity for you to dig deeper and start applying or start preparing a presentation rather to earn better grades and get your final grades to be in the top days. Let me know if you have any questions, and I hope that we can get started after you do the discussions. Please, we have like 3 or 4 discussions that you can have, and they have a presentation due as well. It's an easy task, just do it, and I promise you, you will be just fine. Just like do your discussions and reply to your colleagues and have this kind of engagement, and that will be fantastic. Then we can start talking about the fibers and the FRP applications that I wanted to share with you. You guys have a wonderful day, and I'll talk to you soon.